We're getting near the summary of the unit. What we're looking at is how does space affect us? We want to look at the rhythms on Earth, how the astronomical bodies have profoundly affected life on Earth, look at the hazards from radiation and large objects such as PHAs, and discuss extinction level events that could come from outer space, and explain how leaving the Earth poses hazards for life forms from radiation and microgravity. Hollywood does meteor holes, but never covers these two at all. The rhythms we have from beyond are pretty obvious. The daily cycle, called a circadian rhythm, is circa is circle, dias is day. We are built and sleep and wake on a 24-hour cycle. There is a monthly cycle driven by the moon, and many life forms, including humans, seem to have a lunar cycle as well. The moon takes 28 days to go around the Earth. It causes the tides and seems to cause tides in the human body and other animals. Finally, we have a yearly cycle, which is accentuated by the tilt of the Earth, which causes seasons. The scary part is the sun could be a variable star and flickers like a candle. When the sun flickers like a candle, dinosaurs die.
Excuse the interruption. Any grade 11 students requiring immunizations, please go to the library now. Grade 11 students requiring immunizations at the immunization clinic, please go to the library now.
Sing, sweet bird. The sun is not proven to be a variable star, but on giant time scales, there's some evidence that our sun may pulsate just a couple percent, but that's more than enough to change the fate of life on Earth. The various effects have degrees of significance, and you should be able to sort of explain this. Obviously, the sun and the moon affect the Earth the greatest. We orbit the sun at a safe limit that gives us enough heat and light to allow abundant life on Earth, but the sun can emit bursts of radiation and the light that can hit our atmosphere and cause very common things like northern lights. Less often we get electrical blackouts and satellite damage. Very rarely, possibly life-destroying blasts. Don't lose sleep over it. We've been here recording our history for more than 10,000 years, and it hasn't happened in that time. And the sun and moon together make tides. So that's obviously the one I should have put to the top of this list. The solar radiation from the sun is not just what we see, right? Anything that radiates doesn't just mean nuclear energy. It means light, infrared, ultraviolet. We looked at this in some detail in ecology. Okay, we can only see the visible light, but there's a lot more that comes from the sun. So here's the visible light part of the spectrum, and this is it dropping off outside. So the plot, the red line shows how bright the sun is outside the atmosphere, and the green line is what's left after the air absorbs it. This is the part we see. So it's considerably dimmer on Earth than it would be looking at the sun in space. But way down here is ultraviolet, and you can see the ultraviolet is really quite low here, and look how high it is just outside of space. This is infrared areas. So some of this will be heat from the sun, and it's being smooshed down by the Earth's atmosphere. The main types of solar radiation are radio to visible and UV, and it amounts to 1,400 watts a square meter falling on Earth on average. This is the maximum possible energy we could collect on a square meter is 1,400 watts, landing on an area about the size of 4 classroom desks. So if you have a solar panel that is 1 meter by 1 meter in size and it was 100% efficient and you were on the equator and there was never a cloud in the sky, you could get maximum 1,400 watts of power from a solar panel. This would run a hairdryer. Why don't we have solar powered cars? Cars need about 50,000 watts to run. This means we would need 50 square meters of solar panel fitted to a car to drive by sunlight alone in perfect conditions. So if we made the solar panel 2 meters wide, which is the width of a car, you would be driving along with a 25-meter long solar panel on your roof. There is no conspiracy. Gasoline, unfortunately, is one of the most awesome, powerful inventions we have. And solar power, there's just not enough coming from the sun to run vehicles, not at their current state of efficiency of our electric motors. So it's not happening. Now, what kind of radiation, the nasty stuff, comes from the sun? There's alpha, beta, X rays, gamma rays, neutrons. The alpha and beta rays, they're stopped completely by any tiny bit of atmosphere. You'd have to be outside in space. The alpha particles couldn't get through a sheet of paper. They won't even get through the dead layer of skin on you. They couldn't even penetrate sunscreen. The beta particles will go through the spacesuit. And X rays, gamma rays, and neutrons, good luck stopping them. You need feet of water or lead to bring these guys to a halt. Fortunately, our air is almost 300 kilometers thick and stops these babies cold in the upper atmosphere. But by the time you're on a jet flying somewhere on Christmas holidays, you do get X-rays at the altitude a jet flies. They do reach you. They're harmless to you, but a stewardess or a pilot working their entire career will actually get more exposure to X-rays than many hospital workers. So it is something to consider in that field that high altitude planes do receive X-rays from outer space. Cosmic rays come over from really deep from the Big Bang. And literally, these are the dents in an astronaut's helmet, like a million times magnified, of the dents cosmic rays caused in the helmet. So you can actually examine something that someone said, hey, I bought this, it was in space. You could put it under an electron microscope and go, yeah, it was. Look at the damage. So anybody that says, oh, this thing flew to outer space, came back, or I was abducted by aliens and brought home, we could put his belt buckle under one of these microscopes and look for cosmic ray damage. And you go like, you never left Earth in these pants. Now, I said the cosmic rays come from deep space and the sun makes a solar wind. So there's this constant stream of cosmic rays coming from the universe in general, completely even. There's no source of it. It was the whole universe when it blew up. These suckers are really energetic. They can dent an astronaut's helmet and they're like smaller than a bacteria. But the sun, the particles streaming from the sun are pretty intense. So as the sun blows a wind outwards, there's the galactic wind coming inwards, and there's a point where the two terminate each other. So this is the spot where we define the end of the solar system, is when the wind from deep between the galaxies is stronger than the wind from the sun. And it forms what's called a bow shock. And it's sort of like this. It's like the Earth is making a wind, and here's a wind from outer space. And the two Voyager probes have crossed it. They've proven it was there, that all of a sudden, the weak radiation from the sun coming from behind the ship switches to a radiation coming from the front, and we can go, they are now in interstellar space. So it took from the time I was about your age to now to prove that theory that there really was a transition zone there. We're fortunate that Earth's magnetic field gives us a lot of shielding and knocks the particles away. They spiral through the magnetic field of the Earth and come down on the poles, and we get wonderful northern lights. If the magnetic field disappeared tomorrow, we have a lot of atmosphere. We're not going to be harmed. People on the poles do not get fried when all the radiation is funneled down there. But some of it is blown away. It gets weaker as it travels through the field. So if the field disappeared tomorrow, the big thing you would notice is we could see northern lights throughout the planet. Is the magnetic field important? Yes. We would not receive radiation on Earth. It can't reach us. But if the magnetic field vanished, the radiation could heat the upper atmosphere and our air would expand. That would start dragging spaceships down. So a 20-year flight would turn into like 18 before the ship crashed. But the main thing is the extra heating of the atmosphere would cause more atmosphere to evaporate into outer space, and it could cause the Earth's atmosphere to thin over time. But it would not be death rays from beyond the very second the magnetic field failed. And this is why some planets like Mars, they kind of go, well, lower gravity and no magnetic field, the sun just simply blew its atmosphere off into space. We did a brief little bit on Newton's inverse square law. Basically, This means if you start stepping away from something,